paper, we're going to review inverses and then see how we can use Gaussian-Jordan elimination to help us find inverses. So first of all, in this example, if we wanted to find the inverse using our old technique would say I should find the determinant of A, which would be this diagonal 6 minus this diagonal 5. My determinant of A is equal to 1. So then my inverse from our formula, A inverse would be 1 over our determinant, which is 1. Switch the main diagonal and make the opposite diagonal negative. So here's our inverse. That was using our inverse formula from before with 2x2s. What we're going to do today is we're going to take this same matrix A and use Gaussian-Jordan elimination to find the inverse. And what's going to be nice about this is you're going to be able to find the inverse of a 3x3 matrix without a calculator, where right now, with a 3x3 matrix, the only way we could find an inverse was using our calculator. And I showed you a formula that was so complicated and 5 steps long that there's no way that you'd remember how to do it. Well, I probably could make you remember how to do it. You guys have that capacity. But you don't want to. So this is what Gaussian-Jordan elimination looks like. 2, 5, 1, 3 is our original matrix. And we're going to kind of make it like an equation, but on the other side of the equation, we're going to get an identity matrix. And our goal is to get the identity matrix on the left side. So if you remember with Gaussian-Jordan elimination, step 1 would be getting this to be a 0. And I could change row 2 to equal, I'll probably go row 1 minus 2 row 2. What would that do? Well, that's not going to change row 1 at all. So I'm going to have 2, 5, 1, and 0 still. But if I do row 1 minus 2 row 2s, I will get a 0 here. 5 minus 6 will give me a negative 1 there. 1 minus 0 will give me a 1 there. And 0 minus 2 of those will give me a minus 2 there. Since I want this to be a positive 1, I'm going to change my row 2 to equal negative 1 row 2s. Just going to multiply row 2 by negative. Again, row 1 doesn't change. So we succeeded in getting that bottom corner to equal a 0. I've also succeeded in getting my bottom right corner to equal a positive 1. Next, I want to make that a 0. So I'm going to change row 1 to equal row 1 minus 5 row 2s. Row 2 is not changing, so I just rewrite it. And row 1, this will say a 2. 5 minus 1 will be 0. This will become 6. And row 1 minus this will be negative 10. And again, to get the identity matrix on the left-hand side, I would now have to take row 1 and divide it by 2. Again, row 2 doesn't change. And row 1 now becomes 1, 0, 3, and -5. And I want you to notice that when we do this, what we get on the right-hand side is identical. I'll scroll down perfectly. Look at that. It's identical to our inverse with the other method. Now, for a 2 by 2, probably the other method is still faster. Finding your determinant is not hard. Then doing a little switching around and making some things negative is not hard. However, if we had a 3 by 3 matrix, we can't find the inverse unless we use our calculator. So now this will allow us the ability to find an inverse with Gaussian Jordan elimination. So here's our example 2. And I strategically have chosen inverses, or I've chosen matrices to begin with, that have a determinant of 1. I don't know if you noticed in that first example, it had a determinant of 1. The nice thing about a determinant of 1 is that your answer on the other side is not going to have fractions. If you had a determinant of something else, then your answer is going to have fractions in the end. So, we do our setup. We have the identity matrix starting on the right-hand side. Goal number 1 is both of these to be 0. How nice it is that one of them is already a 0. So I just need to change row 2. How can I make this a 0? Well, I could take 2 row 2's and minus 5 row 1's. Row 1 is not changing. 2, 0, negative 1, 1, 0, 0. Row 3 is not changing. 0, 1, 3, 0, 0, 1. And row 2, if I take 2 of those and minus 5 of those, this will be 0. 2 of these minus 5 of those will be 2. 2 of these minus 5 of those will be 5. 2 of those minus 5 of those will be negative 5. 2 and 0. Switch colors. In Gaussian Jordan elimination, next 0 you want to get is that one in row 3. So I can do that by taking row 2 and minusing 2 row 3's. Again, row 1 doesn't change. Row 2 doesn't change. Row 3, this will stay 0. Question.
Do you have to find the zeros in that order?
Yes.
Why?
If you find a 0 in a different order, when you try to find another 0, you get rid of one of the zeros that you started with. So it's important. The reason these two have to happen first is because then when I add and subtract using row 2 and row 3, these stay zeros because they're already zeros. If you do them in a different order, you can try. You'll get rid of zeros, and then you'll get numbers where your zeros were, and you'll be like, oh, I got to get rid of a zero again. And then you get rid of that zero again, and then your other zero goes away. And so you're sort of in a constant loop of getting rid of one zero, but not being able to get rid of another zero. So now with the purple one, I have to use row 2 and row 3. Because if I use row 1, one of my first zeros would go away. So, but if I use row 2 and row 3, whatever's in the zeros, it's going to be 0 plus 0 is still going to stay the same. So row 2, which is 5, minus 2 rows 1, this will be negative 1. And row 2, which is negative 5, this will be 2. And this will be negative 2. Again, there is no room for any mental math errors at all, so if we make one, everything gets screwed up. Last thing we want to do is we want to make this one positive, so I'm just going to make row 3 equal to negative row 3. These are the steps that are a little bit annoying because you're just having to rewrite a lot. And because you're having to rewrite a lot, you try to do it faster. And in doing it faster, sometimes you forget a negative. So I would say, do it fast, but double check after each step. So all I did was multiply row 3 by negative 1 to get 0, 0, 1 at the bottom. Change colors again. Now we can get both of those to be 0. So for row 1, I can do this easily by adding row 3. For row 2, I can take row 2 and minus 5 row 3s. Notice for both of the orange ones, it's really easy to use row 3 because row 3 just has that 1 in that bottom corner. So that'll be something you'll notice. If you try to use other rows and you get rid of a 0, so now we've got these 3 zeros in the bottom corner. If you do a row operation and one of those zeros goes away, that is not a good row operation. So row 3 hasn't changed. Row 2 is now going to be 0, 2, 0. Row 2 minus 5 row 1s, this will become negative. Row 2 minus 5 row 3s, that will become negative 30. This will become 12. And this will become negative 10. Okay. The big pause was I was doing a bunch of double checking on my mental map. Now row 1 plus row 3, this will stay at 2. This will stay at 0. And this will become 0. And then row 1 plus row 3, this will be 6. Negative 2. And 2. Normally, I would switch colors again. Well, first of all, normally I would have made this a 1. And then I'd switch colors again because step 4 would be making that one a 0. This one is so nice that it's already a 0. So the last thing I need to do would be to make these 1s. So I need to take row 1 and divide it by 2. And I need to take row 2 and divide it by 2. 3 hasn't changed. Row 2 now, negative 15, 6, and negative 5. And row 1 is now 3, negative 1, and 1. Did we label our original matrix as A? So A inverse should be 3, negative 1, 1, negative 15, 6, negative 5, 5, negative 2, 2. And now my life fills with anxiety because I'm going to check. And if you've made a mistake, usually the best option is to start over again. So we're really hopeful and scared at the same time. I'm going to go to matrix. I'm going to go to matrix A. Whoops. Go to matrix. I'm going to go to matrix A and edit. Negative 3 by 3. I'm going to scroll back up to see my original matrix. 2, 0, 1, boom, negative 1. Yeah, nothing like if I type in my original matrix wrong. Two, 0, negative 1, 5, 1, 0, 0, 1, 3. Matrix A is written incorrectly. So now if I go and do A inverse, A inverse. Oh, that's looking promising. I gotta scroll down. 3, negative 1, 1, negative 15, 6, negative 5, 5, negative 2, 2. I was really nervous that could have been wrong. If I wasn't double checking along the way, chances are we could have made a mental math mistake and then everything might have gone wrong from there. Okay, I have one for you to try. Also will have nice numbers. Your matrix we'll call it B.
Did you do this one, JC?
No, I did it wrong.